Number 8 is a proof. It's giving you every statement and every reason, and there's just a couple of blanks here. So we're going to look at this circle with the triangle inscribed. Now it doesn't label it, but it says here that the center point is K. So first thing we're going to do here is label that center point K. Now, so the majority of us like to skip on right to the blanks. So let's go ahead and do that and see if we can get through it. So right before a blank we have that AK is congruent to CK, which is congruent to BK, because they are all radiuses, or radii, so they're all congruent to each other. Now if you look at this triangle, AKC, so I'm going to highlight it here, AKC, what kind of a triangle is that? Well, you can see that it has two sides that are congruent to each other. So what kind of triangle has two congruent sides? Hopefully you said isosceles. And BKC is also an isosceles triangle because again it has two congruent sides. Now we know this because we know the definition of an isosceles triangle. Now we can say that ACK and angle A are congruent because remember, your opposite angle is, your smallest angle is across from your smallest side, your largest angle is across from your largest side. So if you have congruent angles, then their opposite sides should be congruent also. So now we have congruent sides, so these angles have to be congruent. So those are properties of an isosceles triangle. And then that's the end of it. We can go through the whole proof. It gives us all the reasonings. We can prove that angle C is 90 degrees, which means that this right here is 90 degrees. So if you'd like, go ahead, pause the video, read through those, and make sure you kind of get the gist of a proof. For number 9, what do you need to find the circumcenter, and what is it the same distance from? The wording of the question was a little weird. So first we know that the circumcenter is made up of what? Which of the special segments that we talked about? It's made up from the perpendicular bisectors. And perpendicular bisectors are equidistant from the vertices of a triangle. Now it's got a second part to this question, asking about the incenter. The incenter is made up of our angle bisectors. And they are equally distant from the sides of a triangle. So that's all you need to know here. Just kind of go over your special segments in a triangle, know which of those points are made from which segments, and things like the circumcenter that are equally distant from the vertices or the edges of the corners of your triangle, and angle bisectors are equally distant from the sides of the triangle. Certain things like that you'll need to know for questions on your test.